Welcome back to Adventures in DevOps. This week, we turn over some of the largest rocks in the ML tech area as we dive into what it takes to run ML classification. Our guest previously led Meta's text classification infrastructure and is now the CTO and co-founder at TextQL. Welcome, Mark Hay, to the show.
Thanks for having me on.
When I think classification, there are aspects like sentiment analysis, like how does a text read, and entity recognition, identifying relevant aspects, as well as automatic labeling. And I'm sure there's so many more that since I haven't done this in such a long time, even remember at this point. While everyone is focusing on like LLMs, just predicting the next word, we're stuck over here actually trying to solve hard problems.
Yeah, for sure. I mean, I guess like in the sense of, hey, I worked on it at Meta. Fortunately or unfortunately, classification is a lot more primitive than that, just by the definition. The definition was just like, is it like 1 or 0? Like just like true or false. It's not necessarily linked to any specific technique, like not linked to like logistic regression or like GBDTs or anything like that. The thing I worked on at Meta was trying to take in basically every single event that we could on the platform. So that includes Instagram posts, Facebook posts, comments on each one, messages sent, even stuff like likes and friend requests and follow requests, and just like classifying it as like, should we do something about it? Like, is it abusive or not? Abusive meaning like, is it selling drugs, or is it just generally activity we don't want on the platform, or is it even like criminal or just spam, anything like that? And kind of the whole deal was like, how do you know whether something's bad or not, and what technique do you use? It depends. And kind of like being on the classification infrastructure side of it meant that we had to capture all of that. It depends. So on all of these events, we have to run like literally thousands of different techniques, whether that be like regex on like the actual text, looking at like various like language embeddings, like media embeddings, stuff like that, to actually stuff people might not expect. Like people, I think when one says like, hey, finding like spam or bad stuff on Facebook, it's all about like content. Like, can you recognize the image, or can you like classify the text as abusive or not?
Right.
But really, for a lot of it, the vast majority of the value comes from behavioral features. So like features about the graph, like has this person just like sent out too many friend requests to like seemingly unfamiliar people for the last bit, or is there something wrong with like the rate or the unfamiliarity of the folks they're sending it out to, such that you can maybe like classify a drug dealer like without looking at a single piece of content that's actually posted, just by looking at like what is their pattern compared to like a normal person. Like maybe a drug dealer is they get a new friend, or like 5 new friends every week. They send like 2 messages to them, and then they get two more messages from the same person like 3 weeks later, and it happens over and over again. Okay, people try and like hide their activity in the content, but the patterns of what's going on underneath all tend to be very much more easily detectable.
It's the whole woman in the red dress coding in the Matrix, right? Like you can look at the code on the screen and have no idea what the actual message is or what's being rendered for real inside the Matrix, but see the pattern of that, right? And I feel like that's really interesting what you're getting at there, which is that it doesn't matter what the content of the message is. You can just look at the pattern of the content to identify the type of individual. So even if you're obscuring your content or using some sort of code in your messages, you can't necessarily obscure how you interact with the platform. That's quite interesting. And so one aspect is the accuracy, and another one is the scale. As you mentioned, you're doing this potentially thousands of times per request. How do you improve the accuracy really? Like how did you actually identify what the metadata around the connections or frequency rates that a hypothetical drug dealer would take versus someone that's just messaging their friends and family?
The good thing about working at Facebook is that even though we try and do everything in an automated manner, there's still like a huge amount of human reviewers, and that helps a lot in the ground truth, especially for various statistical classifiers that need like retraining. The interesting thing about like abuse classification is that it's like somewhat adversarial. Like they can kind of catch on to like, are you like, what are they catching? What are we catching in their behavior? and then try and change it like back and forth. So we need actually a lot of like readjustment, like rethinking of the approach and so on, simply because you're playing against an opponent, kind of, and your opponent's going to make moves to try and get around that.
Yeah, for
of
sure.
course, like the human people at Facebook Meta are probably a lot better than the robots. I mean, definitely like pre-LLM, this is the case. And so what we do is like we just constantly take out like samples to check, okay, is this classifier like still reasonable or not, or is it like completely fall under like thresholds for like false positive? If we can, like retrain it and try and get back above the threshold. If not, then like go back to the drawing board and see, okay, how do we change our policy mix to actually like better solve the thing?
How do you at scale identify that, say, a malicious actor on your platform has correctly identified what the classification is keying off of and changing their behavior? Like, for instance, well, I guess it's two questions. Number one, how do they learn about where the limits are? Is it that they're somehow creating lots of accounts on the fly and then trying different things and seeing which accounts get banned and using that to reason about your sort of back-end validation system?
I think something like that, along with like trying new content and then seeing like what sticks and what doesn't. The only real way to like stay ahead is by having like a person like look at the data, whether that be in aggregate, like based on their intuition, or even like specific pieces of content to check like what's going on. It might not be appropriate for this podcast, but the specific I always go to is people trying to sell penis enlargement pills. That's probably one of the most that's probably the example I can most clearly remember.
Okay. Yeah.
That's very, you can imagine that's like pretty easy to detect. Like you can just
that's a regex, right?
You can regex or just like OCR some like text and so on.
But because then the text moves into an image, right? Like that's the upgrade. Like first is the text, and then it's like a picture of the text that's in there. And I mean, you see this in a lot of like game forums or community chats, right? Like where they're like, well, what if we misspell some words where everyone still knows what the thing is, but it's spelled in such a way that the regex doesn't catch it? Or like, what happens if we put stars between characters? That's definitely all like first level evasion.
Right. So there's like, write out in text and then like misspell it, like move into an image. Once it seems like we're detecting it in an image, start like putting lines and stuff in the image to kind of like trick a naive like text detector and stuff like that.
It's like a reverse CAPTCHA, I feel like you're going the opposite direction, right? It's
right. You're on the side
you're
of the
trying,
robot, and then
right.
The person, and then like the abusive actor is the one like making the CAPTCHA, trying to go around stuff.
right.
The kind of like highest level is to like go into the symbolic realm, like just have a picture of like two cucumbers, like the left one is smaller than the right one, and then. And like nothing else other than like go to this website or call this number, and then that's really hard.
There's a human contextual problem, right?
But definitely like in generality, like totally unsolved territory without like a lot of cultural expertise.
I mean, there's this interesting aspect here, which is that unlike other adversaries where the target is sort of infinitely far away, whatever the malicious actor on your platform is actually trying to do, they still have a need for their content to be understandable by their mark in some way, right? Because so I can imagine your goal is actually, you don't have to identify the malicious actors on the platform if you can make it that their message doesn't result in any negative impact to the platform. I mean, I feel like the having two cucumbers of different sizes, may be just a legitimate meme that could be there as a real picture that someone could find humorous and not actually in the land of problematic content that could lead someone astray or convert them to whatever.
That could be true. I've never thought about it. Maybe you can get so good that you just like totally exhaust the space of symbols that one might be offended by.
Right, exactly. I mean, like at this point, like, do you ban eggplant emoji? Right, it's so pervasive in our culture, in at least in the Western world that I'm aware of, that it seems like it doesn't do you any good to have concerns over, the printing of that. And then there's another aspect of is it understandable by the other party? And then, so here's another aspect that I've always been sort of curious about. Realistically, there is this aspect of a way to deter someone from identifying what the defense mechanisms are is by separating out in time the moment in which you actually perform, like have a retribution action against a spammer or whatever. Because humans are pretty bad at long-term feedback loops. When an action is performed at T0 and 10 minutes later something happens, your account gets banned, you probably can guess somewhere in the last 10 minutes a violation has occurred. But if you ban them after an hour or a day or a week or a month, it makes it very difficult for them to narrow down what the problem is. So there's like some sort of mean time to like a delay or threshold that you automatically let spammers have so that they're unable to actually understand the merits of the classification system that's in play.
Yeah, no, I think that makes sense. And there, I guess there are kind of ways you can do it. They're consistent with a rule system, like having strikes, for example.
Yeah.
Like
right.
And like you have some number of strikes or you have some number of points, and it's unclear like how many points you get for what. I think that's not something, at least for an individual actor, that's not something they'll necessarily like think about hard. They'll think about like content. But instead, like if we can detect, okay, like who does it seem like they're trying to target? Is their pattern like just someone interacting with their friends, or is it someone like trying to find like new new marks to spam?
Right.
I think that's a lot harder for people to kind of reverse engineer. And like going back to like the cucumber analogy, like totally sidesteps this like trying to like level up in like abstract space, because there's like no there's no like content you can change if like we're not detecting the content.
Right. Well, there's another aspect here that I just thought of, which is that if changing the validation or classification mechanism to better identify malicious actors on the platform just causes them to change their behavior, it doesn't actually reduce the amount of spam or like unwanted messages that you have to process. So it's almost in some way better off to let those messages be sent, not block the user, and then just like send them into the abyss, right? Like it's fine if someone performs a violation on a platform if no one is around to witness it, right? And if you don't ban them because of it, they'll never find out that it was a problem.
Yeah, that's another. I think it's another good one, a good technique for I'll call it like the actual actually passing on judgment, which is like throttling or shadow banning, where we we think someone's like trying to spam a bunch on Facebook. Well, like just let them, but like kind of like pull back on the reach a little bit. Of course, like if you get it wrong, that you're kind of like torturing them, and so you definitely don't want to do that. Not that I on Facebook it's not so bad. Like people definitely like complain about it on say like YouTube. I don't know whether it's actually like abuse reasons or not, but I frequently see like people on YouTube say, oh, I don't have as many views as I did like a year ago. Like is YouTube punishing me? And again, I don't know if it's because they did something bad with their content or not, or if they just like fell off. You can imagine like if they aren't like actually like doing bad stuff, at best, like you feel like your friends hate you now because now they don't interact with your post, whereas they once did.
Well, and maybe this is the thing where you're better off lying about the engagement mechanism, like the engagement metrics for that particular user. Like don't tell them that they're getting less reach. I mean, it doesn't really matter what's in, but I guess you're sort of have this hole to deal with, which is that if users' fundamental goal is to get a larger reach, you want to actually provide them the tools to understand why they're not reaching their actual personal goals or whatever their goal is on the platform. And so you have to deal with this duality, whereas you want to help people who are improving the platform, but you don't want to help people who are diminishing value of it. And so now you have this whole issue of how do we sort of lie to the people who we don't want there so they continue to do things that are easy for us to detect and avoid and sanitize out, and help those that are elsewise.
I guess a good analogy for what you're saying is like ads. Ads in a really uncharitable way are just like legal spam. Like
I don't know if I say legal. It is for sure spam. We can maybe leave the legal part out of it.
Or it's like allowed spam because you pay for it. and what happens when it's like allowed spam that you pay for? Well, like Facebook like does everything they can to try and like increase your reach, provided you're like paying you're paying for it.
Mm.
Like have you ever like ran Facebook ads or anything like that before, or like any paid media?
Oh, me personally, no, for a couple of reasons, but I don't know if that's worth getting into.
Okay, well, like maybe you're selling a thing and you want them to hit the purchase button, or maybe you just want them to look
Right,
at
right.
the thing. It will like optimize that for you. And so,
Hmm.
so that's like the total like flip side of like trying to kill spam. It's
Right.
trying to figure out like what makes your advertisement like seen more by more people, like interacting
Right,
with
right,
them,
right.
like clicking the button at the end of that. I didn't work on that part, but it is kind of funny how they're like two sides of the same coin. If you think about it, it's like what content do people pay for? Try and do the best we can to like be good business partners and boost that as much as we can. And then what kind of stuff we feel like is like a harm to the platform, especially like some people like selling like bad stuff.
Yeah.
And then how do we like do the opposite? How do we throttle that? How do we even like kick those people off?
Yeah. Well, I think the uncharitable view of this is it'd be totally solved if users could control you know what? I know this is such a ridiculous statement. And we know no platform could ever support this, but just have full control over their feed. And then they would be able to say that they don't want certain things in there, and that would be the end of it. Like, you know, I only want to see messages from my friends. And if one of them starts posting pictures of cucumbers, I can probably guess that their account was hacked. And I can stop following them. And that's the end of it. But I do appreciate that in order to make money, companies want to poison your feed with content. And from that regard, you have this problem. You also have the problem of public groups, right? Where you allow anyone to post, and in which case those groups by nature have this problem where malicious actors can come in and post by default.
A really interesting thing we worked on was WhatsApp integrity. You have to look beyond the content to make the best judgment. Well, in WhatsApp, you have to, because WhatsApp content is like totally encrypted. Like you can't like read the messages even if you wanted to. In some circumstances, they can like someone else can like report a message and then you can see it. But that's like at that point they did your job already for you, and you're just like confirming it. You have to figure out everything based purely on like behavioral features, like who's messaging who, like groups and so on. I guess the most obvious thing is every so often I get added to like crypto token like pump group, like number 98. Like I don't even like trade crypto, but I just get added to these groups, and then they say like we're gonna all buy this token, and then
maybe you're missing out.
Yeah, and then
this is your one opportunity.
Buy as well, because you'll be a millionaire if you buy at the same time and sell when we tell you to.
Only a millionaire? I mean, with what the US dollar is at, I feel like that's shooting pretty low there. You know, anything less than 10 or 100 million. I mean, what's even the point?
For like the shit coins that they try and pump, I don't even think they get to a cap of like over 100 million.
I mean, that's pretty interesting about the behavioral metadata that's associated with the messages is actually what you're performing the analysis on. If I had to guess, you've ported some of your learnings and knowledge from working at meta classification over to providing a similar solution to other companies that are doing something. Like, I'm sort of curious, like what is the depth of the technology at TextQL doing?
So if you haven't heard of it or looked into it, TextQL like kind of like ChatGPT, but for querying like data warehouses and databases and big data systems.
Okay.
Doing any of like data engineering, data analysis, data science, and even if you're like non-technical and specifically like even able to like work on like messy data and stuff like that, hopefully you can imagine like the problem or like why someone who doesn't like know SQL or programming might want this capability themselves.
Well, let's talk about the technical side then. Potentially, maybe could give them some inspiration in what they're dealing with. I think historically, a lot of companies had some sort of business analytics. And that was replicated MS SQL databases if you were lucky, or Oracle databases if you were unlucky. And then there were teams who basically wrote SQL on top of that, or managed the SQL, the DB admins, and then teams who didn't understand the SQL and used like SQL crystal reports or whatever to expose the data. And I think the natural evolution is, of course, to throw an LLM-based query at it, and the LLM will generate you some SQL to run against your database. And I think what we realized collectively in the last 6 years or so is that it's incredibly expensive to figure out how to do the semantic search on your database with all the columns and whatnot. And it's also super expensive to put that data in a RAG database or in a vector database in order to perform the embeddings on all of that data that you have for your entire company, as well as perform the embeddings on every single request or query that's coming in and match it to what's in the database. And now I feel like where the world is at, and maybe you can correct me, my limited understanding is that especially most of the more advanced companies have switched to some sort of semantic layer, whereas instead of performing embeddings on the original query and what goes into the database, and using embeddings to do the similarity match, you just parse the schema and run that through your embeddings engine basically, and then match incoming LLM requests or prompts that users have about the data to specific queries. Like you're not dynamically matching in the database, you're dynamically matching a particular query to be able to even interact with the database in the first place. And so you don't have to parse your data. You don't have to run it through an embeddings model. You don't have to run it through an embeddings model every single time you change your embeddings model, which I think historically has been a huge challenge.
No, I think your evaluation of like where did the industry start out and where has it gone is totally spot on. Kind of the current the current like conventional wisdom is to kind of decompose your schema into a bunch of like metrics and dimensions, and then kind of construct these rails such that like you can search over them, and then any combination of like metrics and dimensions you have is kind of like correct by construction. It uses like the right formula and stuff like that. It's interesting you go there because kind of like our approach to TextQL is trying to get to the next stage of where that is. I guess I've neglected to go into this, but like my background is in programming languages. And so my definition of a semantic layer would be kind of analytical definitions on top of a database. So that's one part, like your config layer of definitions. And then the second part is kind of a domain-specific language, like a very simple programming language on top of that config, such that like if you can express a query in that, it is like ostensibly correct if you provide that you like did the configuration right.
It's almost like you're saying that SQL isn't the best language for querying a pool of data.
Well, I guess like it is and it is and isn't. So a semantic layer isn't necessarily good. It is good in the sense that like if you have a query and you can write it in the semantic layer's DSL, it'll probably be right, or at least like you can be assured of like its structural correctness to a degree that you can't with like raw SQL. The problem is that you have to define everything you want to refer to in this like configuration layer. And that takes, and that means you have to write the configuration layer, and then that takes a lot of time. The good thing about SQL is that it's like practically like a Turing complete language on top of like your tables and columns. That means you can express anything, which means you don't have the guardrails. By having this like rigid configuration layer, you're kind of like killing some of the juice that makes people really like using language models, which is the ability to take on like any task in a super flexible manner.
In a previous episode where we talked about embeddings a little bit, one of the things that I sort of identified was that when you do a similarity match in a vector database, so you get in all your data, you run it through an embeddings model, you get out a bunch of binary numbers. I like to think of this as the transformation between like the coordinate system, like X and Y for packets versus the Fourier transform in the frequency domain. So you're changing domains basically. And then you're doing the similarity match by running the same embedding model on the new query that's coming in to figure out whether or not there's data in your database that matches. Now, with that, the thing that was sort of identified is that the values in similarity is an inherent property of the embedding model that you're utilizing, that how close two words are or their hypothetical meaning is going to be based off of whatever, as you said, special creativeness is in the model itself. And so while it's expensive and it may be problematic to manage, especially at scale, switching off of that and moving the flexibility to the SQL layer means you're losing whatever core aspect, whatever I hate to say value or soul was in the original embedding model that allowed it to even perform the similarity in the first place. So I get that. There's also this complexity where it sounds like we were saying that with a semantic layer where we're dynamically generating SQL from incoming prompts, that the accuracy of the SQL generation is still potentially problematic. I mean, you can, of course, try to improve it using guardrails, et cetera. But at the end of the day, you could still end up with a syntactically invalid SQL that you're running against the database. I think that's what you're saying.
I'm kind of describing like two worlds. Like one world is like LLM like writes any SQL it wants. It's the exact same as like giving it your Snowflake credentials in like Cloud Code. And then the second world is like make it like pick the things in the semantic layer configuration that it wants, submit that to the semantic layer program, and then get back correct SQL.
Right.
Now that SQL will be like structurally, at least like structurally correct, provided you did the
Maybe.
configuration right. The problem
If
is
you're using an LLM, you could still end up with hallucinations, right?
oh
So
yeah, sure. You could like refer to stuff that like doesn't exist, or like
Right.
totally misinterpret like the
Right,
user
right.
question.
Right, but I mean, that accuracy is a different problem for sure.
Right. And I guess like I'm contrasting these two worlds as like
Mm.
the semantic layer world, like you get structural rigidity, which is bad for kind of language model creativity, but good for kind of predictability. Exact same as like moving from embeddings to like deterministic text search. Embeddings is like fluid, but you have no idea like how it'll act, and it's super sensitive to like small changes in your pipeline. Whereas like text search is like some text search can be complicated, but at the end of the day, you feel a lot more confident, and you can kind of like pick out if two things are close together, where exactly in the pipeline of like your algorithm did they come to be close together. Whereas like embedding search, you're kind of just like throwing up your hands and saying, I think OpenAI or whoever like trained a good model, and because it's a good model, these two things are close, and so that's probably like actually correct that they should be close.
And so there's a problem with the current state, right? That we've removed some of the, you're calling creativity. I don't know if I love that term, but there is something here that may have captured the intuitiveness that whoever labeled the original data, whoever refined the data sets that were used to train the LLM in the first place, knew subconsciously and included that in the creation of the model. But as we shift layers up, we lose some of that understanding fundamentally of how these two things are related. And like we were talking about the context of the eggplant versus the cucumber, right? And in some contexts, those are very similar, and other ones, they're fundamentally different. And I think this keeps going up, though. I mean, you mentioned the sort of accuracy of the generated SQL. It sounds like an inevitable direction we're going. And I hate that you said that SQL is a Turing complete language, and so that's good. But there is this aspect where we can say that a DSL that is internally consistent and guaranteed to be objectively correct in what we're generating is still better if it's a dynamic DSL, and using the appropriate language and then converting that to something that the database understands in order to do the query in the first place. Is that the eventuality of where we're going with technology in the space to be able to search databases effectively at scale, or is there something on top of that that you're already envisioning?
I guess like the problem I'm trying to highlight is what does it take to actually bring this layer into existence? It kind of requires defining like what structurally correct means for like your database. That's not really like a programming problem. That's kind of I'll call it like some combination of like a social problem and like a UX problem and a project management problem. And that's kind of like where I feel like all of the mines you might accidentally step on in the semantic layer world might lay. Semantic layers, if you use them naively, unfortunately are kind of like counterproductive to this, because they kind of make you define everything before you use it. And that's also like kind of why I brought up creativity. Like what if you want the language model to think about something you haven't like exactly defined already? Well, then you can't, if you're only using the semantic layer, like no, you can't do it. Hence what we try and do is kind of like semantic modeling is great, correct by construction is great. Let's try and get there like incrementally. Like write some like SQL. It'll be wrong sometimes. It'll be right like more than often than you think, though, because language models are pretty smart nowadays, especially if you like connect them to all of the definitions and business documents they actually need to do their work. And then like over time, like incrementally build that up in the same way that like if you're like vibe coding, you're incrementally building up like an application from maybe start with some front end stuff, and you add a database, then you add some endpoints, all of that.
So you're obviously trying to approach innovation in this space in how we're doing searching in large scale databases. Some companies call them data lakes. I guess most of them are actually data swamps, where nothing of value is actually stored in them whatsoever. Where is the challenge today to actually do the query design or semantic search or embedding based search or the correct by construction DSL generation to be able to do the query? Like, where is the biggest challenge in even being able to do that?
Okay, what's like the best system? Like what's the best retrieval system for like data assets? What's the best DSL? Like what's the best like how do we define like a correct like semantic layer with all of our domains mapped out? And like pray that you didn't do it wrong, because if you did, now you have to like go back to the start, like all of the states in between like 0 and 100, and making sure you have a good product like at every point in
Good luck with that. And getting people to actually evaluate if they have a good product, that's for sure a challenge. I'm sort of curious, like, so while you're building TextQL, are you taking insight and innovation from your days at Meta? Is there something specific that you're working on internally that you like right now that seems like it's the showstopper or the next biggest innovation that you're currently working on to achieve?
A big part of like doing classification work is user experience. The users here being defined as like all of the ML scientists and like policy experts and like single region experts who are trying to define these policies without necessarily being like expert programmers, or maybe they are an expert like ML programmer, but they're not like an expert in terms of like orchestrating something to be run at like the millions of requests per second, like QPF. How do you provide like the best representational interface for a non-expert to get as close to expert results as possible? At Meta, the expert results were like perfect classification of spam and not spam. I guess at TextQL, the perfect representation is trying to get to as close to expert level like data science, data engineering, with as little actual like knowledge of the inner workings of those as possible. I've been super into like programming languages and functional programming. Kind of like, even if that's not like, even if you're not designing a programming language for these things, that's the toolkit. The toolkit is to think about like how you represent information the best.
You spoiled this a bit before we went live, how you were secretly at heart a Haskell engineer and that you absolutely love Haskell. And I feel like you're not the first guest on the show for in the recent time that has suggested how great functional-based programming is. And I'm wondering if LLMs have inspired a new level of lack of control over the world and needing to be more refined in how we're actually communicating with the systems that we're building or passing on our expectations. And if this is just our cry for help in the night, to be like, you know what, I'm going to use a functional-based programming language because it's going to make me feel more secure in what I'm building.
It's not really that secret. You can look at my GitHub and see that like almost all the repos are in Haskell. I think you are getting at something. The amount of just like output, whether that be like text or code, that an LLM can do compared to even a team of humans is absurd. Like maybe 10 to 100x, and that's if you're like being responsible about usage of it. And like I think we've all kind of thrown up our hands and said like, okay, like technically we have code review, and I do try and like look at everything
technically we have
like as close to as possible. But at like the end of the day, like people's attention like does slip from like time to time, and like the more volume, the higher pressure there is for your attention to slip when you're like checking an LLM's code or trying to figure out like how something was done, or like whether you just like wrote a huge LLM PR and if you want to like really look at every line before submitting it. I guess like the good thing about like typed functional programming and other like very structural ways of like outputting code or text is that they're like principled like and highly rigorous, and so having that structure grants a level of assurance. Maybe we overstate that assurance because like maybe the principles that like the LLM built the Haskell on are also like suspect. But at the end of the day, it is kind of I think reassuring to see that, okay, I submitted this like 2,000 line PR, and according to the compiler that unless, and compilers have bugs sometimes, but much less than like LLM code. According to this compiler, everything between like the assumptions declared in like the interface and the assumptions declared in the code are the exact same. And yeah, I think that makes people feel a lot safer.
You're definitely getting at a sore point for sure. I think early on, maybe a couple of years ago, there was sort of a controversy where some of the core Linux modules were converted from C++ to Rust, and I believe the goal was to avoid all the sort of problems that Rust solves, memory related, et cetera. As far as vulnerabilities go, and we can be sure that none of those exist in the compiled modules. But the problem was that new issues showed up through the transformation process. And so I think, you know, you're definitely onto something there to say that we are avoiding certain concerns, and maybe it doesn't actually solve all of them. But on the flip side, I think that I am also a little bit more optimistic where we're able to define the semantics or the invariants with our code or our business logic in such a way that actually does give us additional guarantees there. So I can appreciate this migration. I know my own preference is Rust when I can, because I feel like using Rust does avoid some of the complexities that show up in larger systems.
Yeah, I try not to say it like too much because it'll like poison people's brains, but the kind of feeling of like if it compiles it works is definitely
Yeah,
there. Of course, not always true. Like
right.
you can add two when you meant to add one.
Yeah, I definitely agree. Actually, this came up in the episode that we were recording earlier with Cassidy Williams on basically that there's correctness in what we're generating and a commit to getting the correct answer. But more importantly, is that there are vulnerabilities, just safety checks or security issues in what we're building today when we're not using one of these languages that just compiles. And if it compiles, it's correct and it works to some degree, and such that we'll migrate to them because there's clear wins in doing that. And from there are still innovations that we can have on top of that. I think one of them is known as formal verification, which we just can't do with like a scripting language or even a weakly typed language. And this is the aspect of ensuring that what we built or the code that's running is not only syntactically correct, and avoids these sort of vulnerabilities that come up because of memory leakage, et cetera, but is actually doing what the business declared. There's some aspect to the code which makes it objectively correct on a higher level.
If you say like define like your reasonably definable invariants like in the types, and then have your program like off the types. Well,
Yeah.
even with like 10,000 LLM written lines of code per day, you can be rather sure that like the type invariants will be a much smaller service area than like all of the business logic.
Yeah, I mean, I definitely like the optimism there. One of the problems is that like I still think that LLMs tend to generate new stuff rather than pulling the semantics out of what have already been generated. Like we have the same type for a 16 character string generated over and over again, except this one's a 16 character string that represents, I don't know, the order ID, and this one's a 15 to 17 character string that represents the invoice ID. When both of them, still have to go in the same column in the database because it's an auditing table and the foreign key ID, actually has to be 16 characters. And when it gets to 17 characters, is going to be a problem. So, well, thank you LLM for generating the invariant that says the invoice ID.
It likes to break out of like centralized abstractions. Have you ever heard of this like debate or tension between like locality of behavior and don't repeat yourself?
I think it's one of the biggest struggles I've had in mentoring engineers for my last 20 years for sure.
It was like all don't repeat yourself for 30 years. And now I think there's some advocates for locality behavior. I fortunately or unfortunately, an extremely large advocate of locality of behavior or large language models who prefer to do everything within like literally 100% of the logic defined within their context window.
I think this is one of the things that the pendulum swings back and forth to one of the extremes over and over again. Just for context here, for anyone who's not familiar with these ideas, the don't repeat yourself or dry of the solid principles basically says if you're doing the same thing in multiple locations, you should abstract out some sort of abstraction or function or method or class that encapsulates that functionality. So like a sum method if you're adding numbers over and over again, and then just call the sum method. The problem is that in practice, you get extra complexities that are added into it. Like what are the parameters that are allowed in? Are they just strings, and does it parse strings to ints or doubles or floats before it does the arithmetic? What about overflows? What about negative numbers? What happens with irrational or complex numbers? And so do you end up with a single method that's just called sum that, and I'm sure some mathematicians have an opinion here about how you define a group and the operations on the group or on the set in order to decide, whether or not it is a group and whether or not that's the appropriate function. And I'm sure I just lost everyone when I said that. So welcome to real analysis for mathematics and or group theory, really. And so I think that's one thing. The other thing is that realistically, when we are deciding where the aspects or complexity of our program should go, it really does require a little bit of a design philosophy on whether or not it makes sense to do this abstraction and have one infinitely configurable method, which then loses all its value, or have something incredibly opinionated. And obviously the optimal is somewhere in between, whereas the locality of the behavior of the function defines where it's like, well, in this place, we only need to add 2 integers. So we will just write add integers and that we'll be done with that. And we won't care about all these edge cases. But you lose some of the understanding and the expertise that has been brought by building up your single abstraction of the sum method over time. And so I think what's interesting here is to be aware of the controversy or the discrepancy and the duality of the opinions in the space, and then figure out what actually makes sense. And I feel like LLMs this is one of the areas where they fail. And I feel like this stems from all the failures that LLM generated code always has, which is doesn't fully grasp why to pick one of these solutions over the other one. I mean, it will, if you ask it, when should I do this? Like, should I use this, A or B? It will give you a whole list of things, but it's not going to pick the right one for sure. My pick in a previous episode was this paper that compares the Linux operating system to E. coli bacteria as far as the DNA for protein creation, where it says evolution has concluded that the most critical functions are highly replicated throughout the DNA, which in a way represents similarly to what we see with LLMs with the locality of behavior for the functions. Because if a function is so critical, if there's a mutation in that function or a bug that's introduced or a regression, then the whole organism ceases to function. But if you have that same function replicated everywhere, only where it's necessary, and it's a different instance of that function, if one of them introduces a mutation in the DNA, which creates a protein, which means that that thing can no longer function, the rest of the creature or organism still it can survive as long as it's not like, I don't know, handling cell division in some way, or, you know, it does get a cancer and die. And so like there are some critical failure modes, but for most of them, it can still survive. And maybe that mutant form is actually better than what was previously. And I feel like the real challenge is identifying, okay, are we in a scenario where we're creating abstraction that directly duplicates that functionality and has to be the same everywhere? Or are we the Linux operating system where, you know, there's only one version of that module? And if there's a failure there, then that means that every single version of Linux is now susceptible to a security vulnerability because of it.
Wow. Yeah, I never really thought about like redundancy in the code as a potential defense mechanism. I mean, like you might just say like, don't screw up like the single version of the function. I guess like the need for defense is probably 100 times more than than 10 years ago.
Yeah, for sure. I think the wisdom that I've shared here a lot is look at the function that you're creating and decide, is there another function that has the same core values and expectations for how that function should evolve over time as the new one you're creating? And that's not a simple thing to just answer on the fly, but I feel like that's fundamentally the aspect of doing software development, software engineering, is doing this activity. And so we still have to make those decisions. And I feel like people who spend more and more time generating more code are increasingly avoiding making those decisions and understanding what's going on there and skipping that part of the review. And so we're going to end up with a lot of the locality of functionality, but avoiding the question of, does this actually have to work the same? And those are where bugs creep in.
Yeah. No, totally.
I have a lot of controversial theories on this, actually. Maybe I'll throw one more at you. The business value that is created by software you're writing is proportional to the time a human has spent creating that software.
Well, it might be true if you define it as like an upper bound, because there's certainly like random Java product with 100,000 engineers versus like more pleasurable to use product with like 200, right?
Not written in Java.
Like it's not the, I mean, it might be written in Java too, but definitely the legacy one was written in Java. If you define it as like an upper bound, I think that's definitely true.
Yeah,
like,
okay.
Keeping in mind that you can totally like waste human hours on.
Yeah, okay. Yeah, no, I totally agree.
The software.
Sure, right. Yeah, we've seen lots of organizations waste human hours in the name of software development. So I think for sure that that has to be true.
I think like there are claims floating around about like how this or that person is like 100 times more productive with like AI software engineering. I'm not sure I see like 100 times better like software products compared to compared to like 10 years ago. Like ostensibly, like Jira now has like 70% of the or more of Jira developers all use like AI in their coding. Is like the Jira like profit or customer satisfaction or anything like tripled what it was compared to like 8 years ago before anyone was doing AI coding? I don't really think so. So it seems like AI helps a lot, but there is some like underlying variable that like equally influences quality. And AI, like anything or automate anything, doesn't seem to move the needle. The only thing that moves the needle there is like lots of like thoughtful like human like groundwork, at least with the current level of AI capability.
Yeah, you know what? Honestly, I'm like this close to writing a blog post called Warren's laws. Sort of like Maxwell's laws for electromagnetism and the nature of the universe. To like this one is one of them. The upper bound on the relative gain is proportional to the human. There's clearly some value here with using LLMs, and I feel like understanding the core of what it is super important. But maybe that's context for potentially another episode. One of the things I do want to sort of circle back around to, and maybe this is a question that's still relevant in the space, is so it seems to me that you're being very careful about where you're using LLMs in the software development process and how you're interacting with them for the benefit of the customer ingestion for the data, for how you're generating DSLs, or the correct by construction. I love that term. Do you see that there is a corresponding challenge for scale? Like if you only had to perform 100 requests per day against the database versus I think somewhere in the classification architecture for Facebook, you were at 50 million. Does this change your approach for interacting with that data? Or is that sort of like a different orthogonal axis that just talks about how to make the solution reliable? Like, is it, okay, well, when we're doing 50 million, we need to make sure we're using different software languages or doing some sort of performance testing? Or is there a meaningful difference in how we're approaching doing the development or the interaction with the LLMs?
Theoretically, like, yes. I was just writing SQL like at Facebook to do analytics. Like, and underneath the hood, like if you have correct like primitives like sharding for example, like everything should like work structurally the same on like 1 gigabyte to like 1 million gigabytes, right? Theoretically, but it's kind of hard to say, but it's always the case that like when you actually go to the 1 million gigabyte or more scale, like implement like tiny details do always like creep in. You have to like think about how data is distributed, like not just the shard, like on like some function of like the shards. You kind of already broke the mental model with that. And kind of like going to the flip side, like what if you only had to deal with like 10 gigabytes, which is like more often than you think. That's probably like years for TextQL, where all the relevant information could fit in like 10 gigabytes. There's actually like a lot of power that you can get just by saying screw scale. Like I'm not gonna think about this. Let's say I'm at like 10 gigabytes forever. Now I can like use what I call like laptop tooling for everything, like SQLite, like DuckDB, like random like PHP server, like living on like my laptop, like Bash scripts and so on. And the amount of composability you get from like living on like one small machine is like absolutely insane. Like I think you can do the same. Again, it's theoretically just SQL at Facebook too, but somehow if it's just like Bash and SQLite, I can do the same thing like 1,000 times faster just on my computer.
Yeah, I think you're absolutely right. If you only have 10 gigabytes, you're like, well, I can just load this all into memory and then we can do an optimized investigation of whatever the data is. Like querying in memory is just so much easier. We have all the data constructs that we want to use or whatever data structures
like,
that make sense.
Anywhere, like arbitrarily, like all.
Right, exactly. I mean, obviously the challenge is like, how do we load the data in from the database so that it's like exactly in the data structure, which makes it easier or faster to query over and over again. But it's going to be so much faster if we just do that at the start than trying to read from disk. And obviously at scale, you have some of these other problems where there is a real latency between a particular kind of request and another one. If one shard is in this data center and another shard is in a data center that's, halfway across the country or something.
Or you're like trying to query in like the absolute worst way that like takes a tiny scoop from every single shard, which is probably like much easier than than you think.
You just name your indexes wrong, or you didn't even think about doing that in the first place. And why, of course, some data will end up getting sharded ineffectively, and you'll have to deal with that then. But the problem is that I see often a lot of times these show up at scale, but are sort of orthogonal to utilizing LLMs or the technology that we've built up recently, vector databases, etc. It's like almost completely separable until we get to the point where we're like, oh, we want to have LLMs write the source code for us, or the schema, or where the indexes are, because then it will get that wrong, or generate the queries for us, because it won't take into account that whatever our infrastructure is. And so I do see that there is still some sort of meaningful distinction still, but it's not as important as just understanding that at scale there are certain things that we've already figured out and have to do.
Right. I'm like, I guess like the promise of like having the cloud and being able to stand up an entire app from like the AWS SDK is that like it's kind of like the correct by construction version of like DevOps or infra, where hey like I'm using like ECS. It appears to horizontally scale like right out of the box. Or hey, I'm using like Aurora or something. Hey, that also like horizontally scales like right out of the box, or like DynamoDB. But then like you run into all of these, like it's so easy to like accidentally like make some kind of locality assumption, and then like you go up one order of magnitude and everything explodes.
I mean, you say that, and then I just think back to, I think it was a couple episodes ago where we were discussing about RTO and RPO, about handling either malicious attackers like encrypting all your data and how do you recover from that, or losing a data center and how you recover from that. And the clouds don't give you that for free. I mean, it's not even like you pay for it and then it happens. You have to actually invest in understanding what the building blocks are that the cloud provider offers you, so that you can even utilize them correctly. Like you mentioned, like RDS versus Aurora, serverless versus DynamoDB in AWS. One of those provides you multi-region backups and active configurations at scale by default. The other two make it incredibly painful to make it happen, and in practice could be problematic. So I feel like, yeah, I do agree that going to the cloud does solve some of the problems with scale. I think the original promise was more on the lines of the 0 to 1 velocity to make that happen. And over time, I think they've gotten better with adding the necessary building blocks to go further than that. But I don't think the usability or the user experience there helps make people make the right decisions. That being said, maybe that's more of a tangent for one of the previous episodes that we had. So maybe now is a good time for us to switch over to picks for the episode. So Mark, what did you bring for the audience today?
I'm in a hotel room right now. When you sell to other businesses, you have to be on the road a lot. I like to exercise, but I used to always let it go to the wayside whenever I was like on the road or especially busy or anything. And to solve that, I just started doing burpees in my hotel room. That's it. I mean, it's a workout where you're just like standing up and like jumping up and down and doing push-ups. Good enough for me for like a couple day road trip. And it means like when you get back home, like I'm not out of the habit anymore.
I feel like there's always sort of enough room somehow to do a burpee in a hotel room.
Right. Unless you're in some kind of like hostel with just like 6 bunk beds in a 200 square foot room, then yeah, definitely you'll have space. And even if not, like go to the sidewalk and then do them.
For some people, I'm sure that's fine. Honestly, the hallways in the hostels always were incredibly wide, and for some reason, it's like the rooms incredibly small, and double or triple bunks or whatever. But in the hallways super wide, you could absolutely just jump up and down like that. When I travel, I feel like I definitely use that as an excuse not to exercise.
Right. Well, now you don't have one anymore.
You've ruined my whole travel life. My whole conference speaking circuit was always like, this is for me. I travel. I enjoy talking with people and discussing new topics, and I just get to chill out and regress in a lot of ways. And now you're like, well, you've got no excuses left. Well, so a long time ago when I was traveling, I used to try to go, if there was a swimming pool, I used to try to utilize it in the hotel, and if there was an exercise room. But there was definitely a huge barrier to have to overcome in order to do that. Like finding the time in the day to add that in was definitely problematic. And as you mentioned, if you're traveling a lot, like especially in a sales position, you may be traveling 3 weeks out of every month. And then at that point, you're like, well, I'm pretty much just not exercising ever. That week I get back, that's for me. I have to then relax and recover during that time.
Right.
So you pretty much completely avoid exercising compared.
I think the thing about, or like whatever exercise you can do, just like standing up in like the space you are right now, is that it like totally removes the friction. So I mean, at minimum, the like frictionless thing is like just like burpees, do like 100 or something, or like split it up as well. And then if there's an exercise room, then I can build up the motivation to go there and like do like pull-ups or like exercises or run or something. All the stuff that like burpees doesn't like cover super well. But once you realize you can do exercise like right in your room, then all that stuff just a cherry on top, and you already like passed the test, so to speak.
Do you change your exercise routine based off of where you are? Like if you're not traveling, you do one set of things, and when you're traveling, you do something separate? Or
Once I'm home, I actually have a gym and stuff. I definitely go for like way more diversity. Like if I was only doing burpees forever, that might be like bad. It seems like you get some kind of muscle imbalance from doing that. So I guess compensate on the other end by trying to mix it up as much as possible when I do have the motivation to do other stuff.
do you also exercise while you're on vacation?
Not nearly as much. Maybe a couple of days.
I like the recommendation. Okay. I actually wasn't sure what I wanted to share, but I found for my pick a article called "I Left Port 22 Open for 54 Days." It's by Arman Hossein, and there's some interesting conclusions. So like SSH server running on port 22, and you get to see what people are doing. What does the internet try to do with your port? And what's really interesting are like the conclusions that he finds from it. Like I don't know what you would expect to have happen. So it wasn't a real computer. It was like a virtual machine that was specifically set up to capture and respond to certain.
I guess like someone would like do some like Bitcoin mining program on it,
Well,
like ransomware.
Yeah, well, that's the thing. As an attacker, you figure out what the optimal thing is for you to do with a machine that you find that you can SSH into. And that means from a defense standpoint, you may be interested. What are people trying to do with my server so that for my actual servers, if I wanted to configure them in some way to deal with malicious attackers, I can look for a same sort of signatures. So a question is like, well, what did he actually find? The interesting thing is that most of the attacks that were done, like Bitcoin miners or whatever, were just basically an automated command that was run straight against the machine, like SSH in, trying any password. They get the password, it works, and then they just run a single command, usually a CNC-based command or C2 infrastructure. Basically, it would be a single command which would pull stuff from a third-party server that the attacker owned to run infrastructure on that machine, like a Bitcoin miner or whatever. And if you run, Bitcoin miner.start, the fake server would just respond, okay, like it's running, right? And that's it. End of story. And so the attacker, thinks it worked, and then they go away, and you capture the signature of what these attackers were doing. And so you can capture all of the C2 command and control servers that were in effect, that were currently being used at this time by proportion and whatnot. And what he found is that like 99% of the attackers, the visitors that went there, never went on beyond like a single command. Basically, they found the open server, they attempted to authenticate with one of like 1,000 most common used username and passwords. Then they run the result, and that's it. They're done. They disconnect, and the server just keeps on running. Some of those actually attacks didn't even run the script in the background. So as soon as they disconnected, it just stopped the attack. The miner just would stop at that point. Like the command wasn't even sufficient. But like in the top 1%, there was actually some really interesting stuff going on. Like he could tell how sophisticated an attacker was based off of the type of command that they were doing. Like, were they running something that would get saved in the user's bash history for authentication? So like if you went in later, you'd be able to see this in the history. Well, there was like some clearly state-sponsored actors, some from the probably French government with French IP addresses that were disabling bash history and using direct port protocol to handle messages and whatnot to completely avoid getting anything logged. Most of it was crypto related in some way. People trying to run Bitcoin miners, or because Bitcoin is worthless, Solana, which is much cheaper. You don't need infrastructure to run Bitcoin miners. I think it costs. I think right now it costs more to mine a Bitcoin than Bitcoin is worth. So people who mine Bitcoin are only doing it on with malicious intentions, which I think is absurd.
They're doing on budget, basically.
Yeah, for sure, right? You get some cloud credits and you run it, you hijack someone's account and you run it, right? You're not doing it. I mean, if you're really smart, you use Monero instead because it's untraceable. So no one can track that these are from the same account or potential threat actor. But a lot of it was complete garbage. That wasn't very smart. They weren't doing something very interesting. Some people were just curious, like, oh, I found a server. I'm going to SSH in here and see what I can do, and then run some interesting commands. A lot of them were just running LLS to start. Like, where am I? What do I have access to in this directory? I don't know. I found this article so interesting.
It's cool how the sophistication follows kind of like a power law. That's one. Two, it's kind of funny. It's not clear that anyone like benefited significantly from the successful attack on the server.
Yeah, no, for sure not.
Maybe someone got enrolled. Maybe got enrolled into like a botnet or something. That'd probably be the best outcome out of what I can imagine for the attacker.
So outside of the Bitcoin or crypto mining, there is a small section where they were basically just recording metrics about the actual machine. So like where it was, its IP address, what it was actually running, which version of Linux or distribution, Ubuntu, Kubuntu, whatever, Gentoo, etc. For what presumably would be a later attack, so that later they could come back and be like, oh, you know what, we want a machine in this region with this IP address so that we could use. And so it was just about fingerprinting the actual machine. And a lot of the messages were from that. Yeah. So like I said, really interesting. It's not very long. It's like a 20-minute read. Pretty interesting article.
Cool.
Well, thank you, Mark, for joining us today and telling us all about the classification at Facebook and what's next in the semantic layers. I already hear that semantic layers are over and done. We're already on the next great thing. So always interesting to hear that the latest tech is now obsolete.
Right. Just until the next one, until your next guest tries to add another generation.
Until next week, where we find out that the replacements for semantic layers is already obsolete. I don't remember what next week's episode is at the moment. But thanks to all the listeners for tuning in for this week, and I hope to see everyone back next week.